Bismillah ar-Rahman ar-Rahim. Today, inshallah, we will start with the first class of the IGCSE. We will take the common classes between the three boards, AQA, CIE, and Edexcel 1. We are dealing with the students in this level as a beginner. That's why we're going to start with them from the beginning of the chemistry, from the first word in chemistry, which is matter and the states of matter. And today we'll talk about this topic, which is the states of matter. So today, inshallah, we'll start with this topic, states of matter. From the previous information, you know what the meaning of the word matter. Anything that has mass and volume is counted as matter. So the two conditions required for this matter is mass and volume. Somebody will tell me, well, anything around us has mass and volume. That's right, everything around us counted as matter because it has the two conditions, the mass and the volume. But don't forget, all of the physical quantities are not counted as matter. And when you said force, this one is what? No matter. When you see heat, it's no matter. All of emotions are not counted as matter. Love, no matter. Like, no matter. If a matter is anything that has mass and volume, this one, as I just said now, everything around us. We have three states of matter. States of matter, as you know from the previous class, are three states. They are the solid, liquid, and a gas. To study the three states of matter, you need to know a theory explaining everything about the matter, which is known as kinetic theory. Well, kinetic theory is a theory which is explaining everything about matter. The kinetic theory which we have giving us three main assumptions. Those three main assumptions can be applied for all states of matter. First one, you're supposed to know that matter is made of tiny particles, and those particles known as molecules. If a matter is made of tiny particles, and those particles are in a continuous motion. Even particles which we have are in a continuous motion. And you're supposed to know this motion increases by increasing temperature. If a motion of particles increases by increasing temperature. By a three assumption again, if you don't mind, matter is made of tiny particles, particle in a continuous motion, motion increased by increasing temperature. Again, I'm repeating it for you. Matter is made of tiny particles, particles are in a continuous motion, motion increases by increasing temperature. Matter is made of tiny particles, particles are in a continuous motion, motion increased by increasing the temperature. Those three assumptions will be applied for the three states which we have, the solid and liquid and gas. So will you please, a simple representation for the three states which we have is like this. This one, is the solid, this one is the liquid, this one is the gas. The particles here, or this one, is made of tiny particles, and the particles are in a continuous motion, and the motion increases by increasing temperature. The three rules apply for the solid. For the liquid is made of tiny particles. Particles are in a continuous motion. Motion increases by increasing temperature. This one for the liquid. The three rules apply also for the gas. This made of tiny particles. Particles are in a continuous motion. Motion increases by increasing temperature. So what is the difference between the three states? Simple comparison can be done between the three states which we have. Simple representation can be done for each one of them. If we're going to make a simple representation, this one is made of tiny particles. So the particles here, as you know from the previous year, it will be closer and regularly arranged. Closer and regularly arranged. The particles which we have here will be closer and irregularly arranged. The particles which we have in gas will be far apart, away from each other. But this one is the arrangement of particles which we have in case of solid and liquid and gas. And this one will be the point, or the first point of comparison which we have. As we did say, if you're going to make a comparison between anything, you're supposed to decide the point of comparison before starting this comparison. For example, I'm going to say the arrangement is one of the point. I mean the arrangement of particles. This one is regularly arranged. This one, mazboot, this one is irregularly arranged. This one is close, and this one also, the particles close to each other. These particles close to each other. This one far apart, or completely away from each other. But the first point of comparison which we have, close and irregular, close and irregular, and far apart. This, if you're going to use arrangement as a point of comparison. Remind me with the kinetic theory, if you remind what it say, any matter is made of tiny particles. Here it is. This is the particles and is the arrangement of particles. The second one said particles are in a continuous motion. So the particles here moving, and in the third case, particles also is moving. How the particles are moving in each one of those cases here. The time of motion which we have, because the particles here close to each other, regularly arranged, they have no chance to move away. They can only move in their position in a motion known as vibrational motion. But the kind of motion which we have in the solid is vibrational motion. The motion which we have in case of liquid. As you know, particles can slide over each other. So this one we call it sliding motion. The motion which we have in case of gas, because the particles away from each other with no attraction force, they can move freely. In a motion we call it random motion. What's random motion? Random motion is the motion in all directions with different speeds. Again, I'm repeating it. What's random motion? Random motion is motion in all directions with different speed. If you get some small particles like pollen grains or even smoke particles, and you observe the motion of those particles under the microscope, you will observe the motion by this way, moving up, moving down, moving right, moving left, like this. This zigzag motion, known as Brownian motion. This one, the Brownian motion, is the motion of the small particles because of the collision takes place between the air particles and this small particle. But this one is the bowling green, the air particles or the gas particle will collide or hit it from this side, so it will move in this direction and then from this direction and so on. Different collisions takes place, make the bowling green move in a zigzag motion. This zigzag motion, as we say, counted as Brownian motion. This one, Brownian motion, do not confuse between the Brownian motion and random motion. Random motion is the motion of the gas particles. Brownian motion is the motion for the small particles caused because of the collision with the air particles. This one about something we call it random motion and Brownian motion. The third point of comparison, which we have between the solid and liquid and gas, you can put any one of the point of comparison. I'm going to put the intermolecular spaces, the space between the particles, for example. There it is. We have no spaces between the particles in case of solid and liquid and gas. Sorry, in case of particles in case of solid, because the particles are regularly arranged and close to each other. In case of liquid, because of the irregular arrangement, we have smaller spaces, as you know. In case of the gas, because the particles are completely away from each other, we have a larger space between the particles. You can talk about the attraction force between the particles. It's also kind of a comparison point. Attraction force between the particles in case of the solid, very strong. That's why the particles close to each other. This one is counted as a weak attraction force. That's why particles can slide over each other. Almost no attraction force between the particles in case of the gas. That's why each one of them is moving freely, random motion. This one, if you're going to put the intermolecular forces between the particles or the attraction force between the particles in the three states also. If this one is a simple comparison between the three states, solid, liquid, and gas. I'm going to use the arrangement as one of the point of comparison, close and irregular in case of solid, close and irregular in case of liquid, far apart or away from each other in case of gas. The motion is vibrational motion in case of solid, sliding motion in case of liquid, random motion in case of the gas. Almost no intermolecular spaces between the particles in solid, small intermolecular spaces because of the irregular arrangement in case of the liquid, and we have large space between the particles in case of the gas. Strong attraction force. At the solid, almost no attraction force between the particles and the gas. The next one about the comparison or simple comparison between the three states, solid and liquid and gas. We have factors affecting the states of matter. One of them is the temperature, which we'll talk about in detail, and the other one is the pressure. The states of matter can change from one state to another state by the action of temperature. You can change the solid to be a liquid, and the liquid can convert into gas. Even the solid can convert into gas, or the gas can also convert into solid. From the solid to liquid, this process known as melting process by heating the solid. This process known as the melting process. From the liquid to the gas, this one known as the boiling process. Sometimes we're going to say this one is evaporation. It's the same. Or can be accepted as a change of state. I'm going to write boiling now, and in a few moments I'm going to compare between the boiling and evaporation. From the gas to solid, this one is abnormal change, counted as sublimation. How about if I would like to change from the gas to liquid? From the gas to liquid, this process known as condensation. From the liquid to the solid, this process known as freezing, or you can say solidification. Now I'm going to talk about this one in detail. If I have a solid substance in a container like this, let's say we're going to start with ice. This one is the ice cubes, here it is. And I'm going to start heating, and I have a thermometer here. Let's say the temperature around -10, so I'm going to start from -10 here. And I'm going to, this one is the time required for this process. And this one is the temperature. I'm going to start heating. So by heating, the temperature will start increasing. Increasing and increasing till a definite point will not increase anymore. While I'm heating, yes, while you are heating, the temperature stops increasing. Or the increasing temperature stopped here. After some time, that temperature starts increasing again. And then stopped again. And then increasing again. Let's explain this diagram. You started from the solid. After some time, the solid starts melting. So when you have horizontal line like this, that means we have a change of state. The heat energy is converting here to internal energy, or the chemical energy I just said before. The state converted from solid to be a liquid. So what do we have at this horizontal line here? We have a physical change. This one changing from the solid to the liquid. And after that, the temperature of the liquid will start increasing to a definite point. The liquid will start boiling. You know, what do we have at this horizontal line? Boiling process. And then we'll get the gas. At this part, we have melting. At this part, we have boiling. Why do we have constant temperature here? Because we have a change of state. All of the energy will be used to change the type of motion from vibrational motion here into sliding motion here, known as latent heat. All of the energy here will be used to change type of motion from sliding motion here to be random motion at the gas. So what do we have? Heating, constant, and heating and constant, or increasing temperature and then constant, increasing temperature and then constant, increasing temperature. During the constant, we have a change of state because the heat energy counted as or converted into internal energy. What is that point exact? This one is the melting point. What is the process which we have here? The process which we have here is the melting process. What's melting process? Changing of state from solid to liquid. What is the melting point? I know somebody are going to take temperature at which the solid converts into liquid. It's accepted. But as a professional person, you're supposed to know the melting point is the temperature at which we have equilibrium between solid and the liquid. I'm repeating it. Melting point is the temperature at which we have equilibrium between solid and liquid. The same thing for this point. This one is the boiling point. Temperature at which we have equilibrium between the liquid and the gas. You can observe also solid require the energy to convert into liquid, liquid require the energy to convert into gas. So you will give energy to the solid and you will give energy to the liquid to move in this direction. Moving from lower energy level to a higher energy level known as endothermic process. Now we'll talk about the thermochemistry later, but now just for this process, this one is counted as endothermic process. This one is counted as heating diagram. Another diagram can be applied for the gas. There is a gas converted into liquid, converted into solid, cooling diagram. This one is gas, this one is a liquid, this one is a solid. But this process is a condensation. This process is a melting process. And this counted as exothermic process, and all of diagram known as cooling diagram. If this one's heating one, this one is a cooling diagram. If the two diagram simplify for us the change of state and explaining it for us. What will happen to the solid particles already when you heat it? You just said solid is made of tiny particles. Yes, this one is known. Particles are in a continuous motion, and motion increases by increasing temperature. So once you heat this one, what will happen? The motion of particles will increase. What's the meaning of this word? The motion of particles will increase, covering longer distance with higher speed. So the particles will start moving here, moving here, moving here, moving here, moving here, and so on. All of the particles will cover longer distance. That's why the substance which we have will expand. What's the meaning of this word? Expansion, increasing in size as a result of increasing temperature. More temperature will be applied, more heat will be applied for this substance. Enough space will appear here, enough for sliding motion. Now, the kind of motion which we have for the solids, what is vibrational motion? Why it's vibrational? Because there is no chance, there is no space for any other kind of motion. Like once you heat, you will create small spaces. Those spaces are enough for the other kind of motion, which is known as sliding motion. Once you have a sliding motion, that means you have a liquid, not solid anymore. The same thing, I'm going to apply it here. I'm going to heat more and more. The motion will increase more and more till the particles gain enough energy to overcome the attraction force between them. Once the particles gain energy, which is enough to overcome the attraction force between them, the particles will move freely. It's not attracting anything. Khalas. It's okay. Moving freely, random motion now. This process here is melting. This process here is boiling, or you can say evaporation. Again, what's the meaning of these words? Boiling and evaporation, changing the state from liquid to gas. And what's the difference between them? The boiling and evaporation, the point of comparison between them, as we did say, before starting any comparison, I have to decide what's the point of comparison. The meaning of each one of the same. Change of state from liquid to gas. This one, the meaning of each one of them. So what's the difference between them? The temperature. What's the meaning of this? The boiling has a definite temperature. For the water boils at 100, evaporate at variable temperature. But this one is a fixed point, this one is a variable point. The location. The boiling takes place through the liquid. Any particle has enough energy to overcome the attraction force will move away and move randomly. Like in evaporation takes place only at the surface. If this one takes place through the liquid, this one takes place only through the liquid. Surface here and through the liquid here. The rate, which one of them is faster? The boiling is faster than evaporation as it takes place at higher temperature. Even you can say the boiling is the fastest rate of evaporation. But this one is faster, this one is slower. We have faster over here, and this one is slower, as you just told me. This one is simple comparison between the boiling and evaporation. And this one, the change of state, as we just said. Just remind me quickly, you have a solid, and you have liquid, and you have the gas. From the solid to liquid, from liquid to gas, all of this require the energy and known as endothermic. The process known as melting, the process known as boiling. The opposite way, from liquid to gas, from gas to liquid, and from liquid to solid. This one required cooling down, absorbing heating. You will absorb the heat from the gas. And this one is counted as exothermic process. From gas to liquid, this condensation. From liquid to solid, you can say freezing or you can say solidification. From the solid to gas, direct change, known as sublimation. Those are the change of states which we have. We have a small evidence for the motion of particles, this one known as diffusion. Diffusion. The word diffusion has many definitions. Motion of particles from high concentration area to low concentration area. This one is diffusion. Diffusion is spreading out of substance in all available spaces. This also counted as diffusion. Diffusion is a great evidence for the motion of particles. If I have a cup of water, I'm going to put in this water copper sulfate, CuSO4. This one is the formula for the copper sulfate. And I will talk about copper sulfate and the formulas, all of this one later. Like this is the formula for copper sulfate. Once you put it here, you will observe a blue spot appears here, and the blue color start distributing in all of the solution till all of the solution is uniformly blue. Because the copper sulfate will convert it into hydrated copper sulfate, which dissolve in all solution. And this dissolved copper sulfate will diffuse in all of available spaces. I'm repeating it. So we have a copper sulfate particles here, and we have available spaces. Do we have available spaces in liquid? Yes, we have. We just said particles are close, but we have small spaces. Because we have small spaces in liquid, diffusion takes place in liquid. However, if you're going to make another experiment with drop of ink, or you're going to make it with potassium manganate, KMnO4, known as potassium manganate. The same thing we repeated here. Purple color will start appearing and then distributing in all, spreading out in all of the solution converted into purple. Dissolving takes place and then diffusion takes place in this solution. The diffusion takes place in liquid because we have small spaces. Small space between the particles of liquid. That's why the copper sulfate particles can diffuse, can spread out in all available spaces. That's why the particles of potassium manganate can spread out in all available spaces. Also, we have available spaces in case of the air. That's right. I'm going to take two gas jars, putting by this way. This one is the first gas jar, and we have a separate lid between them. We have bromine here. Bromine. This one is a volatile liquid, and its color is reddish brown. Liquid. Here it is. Maybe this one is bromine. Do we have only bromine here? Actually, we have bromine, and also we have air. We have air here. Once you remove this lid here, what will happen? The bromine particles will start spreading out. That's why you will observe all of this area are colored. You can say rich brown, or you can say orange. So the bromine gas spread out, diffused in all available spaces. All available space between what? Between the air particles, as they have a larger space between them. If I have a glass container or a glass surface like this, and I'm going to put the bromine in this surface, do you think the bromine will diffuse inside the glass? No, for sure. Why? Because this one is a solid and no intermolecular spaces between the solid particles. So diffusion never takes place in solid, as there is no available spaces between the solid particles. The diffusion takes place in liquid. Diffusion takes place in gas, and takes place in gas faster than liquid, as we have a larger available spaces. Diffusion will never take place in solid, as we have no intermolecular spaces. And as we did say, diffusion is spreading out of a substance where in all available spaces. Why? Because of the continuous motion of particles. I'm repeating it. That's why we are counting it as evidence for what? For the motion of particles. Diffusion is spreading out of particles where in all available spaces. So you need available space for diffusion. If you have no available space, no diffusion takes place. Why? Due to the continuous motion of particles. Don't forget, we have another definition for diffusion: motion of particles from high concentration area to the low concentration area. This one for diffusion. We have many factors affecting diffusion. The main factor affecting diffusion is the mass of the particles. And this one is inversely proportional. Inversely proportional. Two kinds of proportional will take it during this year. One of them is counted as directly proportional. The other one is counted as inversely proportional. That directly proportional, if A is directly proportional to B, that means A increasing, so B will increase by increasing A. If this one is 10 and this one is 20, this one converted to be 40. 10 multiplied by 4 gives you 40. This one has to be multiplied by the same factor. Or you can make it something, we call it cross multiplication. 40 times 20 divided by this 10. It will give you 80, as you know. 20 times 40 divided 10 gives you 80. The kind of proportional which we have today is inversely proportional. Rate of diffusion with the mass of the particle, we can count it as molecular mass. Here it is. If A is inversely proportional to B, by increasing A, B will decrease. If this one is 100 and this one is 50, now this one converted to be 50. This one will be what? It will be 100. This one decreased, this one increased. This one known as line multiplication. 100 times 50 divided this 50 will give you 100 here. 100 times this 50 over the other 50 gives you 100. So if we have two kinds of particles, particle A and particle B, this one was mass 100, this one was mass 50, and they start moving at the same time, which one diffuses faster? The 50. Even you can find the relationship between the distance which we have here and here, line multiplication. 50 times distance equal 100 times the distance which we have. Can be used by this way, will be helpful for you. We can make an experiment for this issue. We can get two substances, one of them known as hydrogen chloride gas, the other one known as ammonia gas, NH3. The mass of this ammonia is 1 nitrogen, which is 14, and 3 hydrogen, which 1. So all of it will be 17. The mass of this hydrogen chloride hydrogen 1 and chlorine 36.5, so it will be 37.5. Counting the molecular mass, we're going to take it later, and it's more essential for you to know how to calculate the molecular mass now. As I said from the beginning of this topic, we're dealing with the students at the beginner, and we give him everything from the beginning. Now I'm going to continue from mind. I have a gas, hydrogen chloride, I have ammonia. This one start diffusing this way, this one start diffusing in this way. Because ammonia is lighter than hydrogen chloride, diffuses faster, covering longer distance. That's why you will observe the two gases will meet in this point, which is closer to HCl. Why? Because ammonia, lighter than HCl, diffuses faster. I can make the other experiment, or this experiment a different way. Can we? Yes, we can. If I have two gas A, and this one is gas B. I don't know the two gases, but this one start diffusing here, and this one start diffusing here. And the reaction takes place at the center exact. What can you conclude from this? What can you deduce from this issue? A diffuses with the same rate as B. And so the mass of A is equal to the mass of B. Did you get it? Yes. If I have a container like this with a small hole, I have many gas, gas A, and gas B, and gas C. The mass of this one, say 50, and this one is 30, and this one is 15. Which one of them diffuses faster in getting out of this container? The C. Which one will be with the highest concentration after several times? The A. Even this method can be used for separating gases. The one with higher rate of diffusion will leave the container earlier and faster. And the one with a high concentration will stay at the container. But this one is a diffusion and the action of the molecular mass and the rate of diffusion. For this experiment, when you have HCl and you have ammonia NH3, we did say the mass here is 37.5, the mass here is 17. This one diffuses faster than this one. That's why the chemical reaction takes place at the center here. This ammonia reacts with this hydrogen chloride, giving us ammonium chloride. That's why you will observe here a white solid. You can say white cloud will be formed here. And this white cloud is ammonium chloride. Will be formed in this area, closer to HCl, as ammonia diffuses faster than HCl, as we say. This one about something we call it diffusion. The last part which we have in the states of matter, predicting the states. I'm supposed to predict the state. Is it solid or liquid or gas? I have a simple question. Ask. If I have a solid substance in front of me, why this one is a solid already? You're going to tell me because the particle is closer and. I'm not asking you to give me the character of the solid. I'm asking a simple question. Why this one is a solid now? Because the room temperature is not enough to melt it. So its melting point higher than the room temperature. But if you find a gas, why this one is a gas? Because the room temperature enough to boil it. So it's boiling buoyant, lower than the room temperature. If it is a liquid, but the room temperature enough to melt it, like it's not enough to boil it. By using melting point and boiling point, you can predict if the solid, if it's a solid or liquid or a gas, or you can predict the state of matter as just said. For the solid and liquid and a gas, we can predict the state of matter as we did say using the melting point and the boiling point and the relationship between them and the room temperature. In case of solid, it has high melting point. And the melting point in this case more than the room temperature. And for sure, if the melting point higher than the room temperature, the boiling point also will be higher than the room temperature. The boiling point is higher than the melting point. For the liquid, we did say the room temperature enough to melt it. So the room temperature is higher than the melting point, but it's not enough to boil it. So the room temperature will be lower than the boiling point. This one, sorry, the room temperature. For the gas, the room temperature will be higher than both of them. So this one is counted as a gas. You can make a simple representation. You have the melting point here. You have the boiling point here. And you have something, we call it the room temperature. If the room temperature lower than the melting point of the substance, this one will be a solid. If the room temperature higher than the boiling point of the substance, this one will be gas. If the room temperature in between, this one will be counted as liquid, as you told me. And if I said the room temperature is 25, this one is the room temperature. I have a substance A and a substance B and a substance C. For each one of them, the melting point is given, the boiling point is given. And you need to predict the state. Is it solid or a liquid or a gas? The melting point here was 20, the boiling point here 120. The melting point which we have here was 30, the boiling point was 170. The melting point which we have here minus 40, and the boiling point which we have is, say for example, 24. Let's start. 20, the melting point is lower than room temperature. See, you can find the position of this temperature. Is it in between or after or before? What's the meaning of that? If it is in between the melting point and boiling point, like this case, but this one enough to melt, like it's not enough to boil, but this one is liquid. If it is before the melting, but this one is not enough to melt, but this one will stay solid. If this one is higher than the boiling, here is the location, the position. But this one is a gas, enough to boil. This is how to predict the state of matter. So if the substance has high melting point, it will be a solid. Has low boiling point, it will be a gas. High melting point will be a solid. High boiling point, low boiling point, this one will be a gas. I'm repeating it, maybe I confused. High melting point for the solid substance. Low boiling point for the gas substance. This one for the state. If you have low melting point and high boiling, and I have low melting point and high boiling point, but this one is liquid substance. That for the states of matter. After finishing the states of matter, you're supposed to test the purity of the substance. Purity of the substance can be tested using this one for the purity of the substance. The melting point, the boiling point, or using a method known as a chromatography. Those are the three methods which you use to test the purity of the substance. I'm supposed to test the purity of substance using the melting point or boiling point or the chromatography. For water, for example, H2O with the water, as you know, the melting point is 0, the boiling point is 100 for the pure water. This one for the pure water. If the water is impure, we'll observe that the temperature will be lower than 0, around -4, for example. The boiling point will be more than 100. It will be 102 or 104 or anything. So the presence of impurity decreases the melting point and increasing the boiling point. This one for the presence of impurities. And in this case, you have impure substance, so you need to purify this one. So you have a mixture of substances. And in this mixture, you need to separate the component that you need. How can you separate this one? Just go to the science lab and start separating process. If you're going to science lab, you need to measure something. Yeah, we have a group of measurement in science lab, we're supposed to know it. For example, you need to measure the time for any experiment. You need to measure the mass of the experiment. You need to measure the volume. Also, you need to measure the temperature. How can you measure the time? That's right, as you told me, by stopwatch. And the unit will be the second. How can you measure the mass? Exact scale, the balance. And the unit will be gram. How can you measure the temperature? Thermometer. And in IGs, we're going to use only one unit, which is the Celsius one. The Kelvin we're going to use in the AS and A2. How about the volume? Volume of what? There it is. Maybe for a solid, two kinds of solid you have, regular structure and irregular. For the regular, you're going to use the mathematical rules. Length times width times height, area base times height. How about if it is irregular? Irregular by water displacement. You will get a measuring cylinder, pouring some water with a definite volume, and then add the object to this water. This one is V1. After adding the object, we'll convert it into V2. The difference between V2 and V1 is the volume of the object, known as water displacement method. How about if I have a liquid? Two kinds of measurements which we have. One of them is accurate, the other one is approximate. Approximate one using measuring cylinder, normal measuring cylinder. Accurate one according to the value which is needed. Do you need multiple of number 5? You need 5 and 10 and 15 and 20 and 25. You can use either pipette or a burette. But for the accurate which we have here, don't forget, you need multiple of number 5 or just any number other than multiple of number 5. And for example, maybe I need 13.3. For example, 13.3, you cannot use the pipette. Till you are going to use graduated pipette, this is something else. You are going to use a burette here. In this case, you are going to use both pipette or burette. Both of them can be accepted. How about if I would like to measure the volume of the gas? Measuring volume of the gas or just collecting gas? The method of collecting the gas, you know them if you would like to collect the gas. Method of collecting gas, yes. It is either by air displacement or water displacement. If the gas which we have is insoluble, I'm going to use the water displacement. If the gas which we have is soluble, I'm going to use air displacement. How can you make the water displacement? Carry out an experiment in a closed container like the conical flask. Take a delivery tube. And the gas jar filled with water. Fill the end in a water container like this. The gas will start moving up, displacing the water. How can you make air displacement? It's easy. The same way like it was no water. Gas moving here or moving down here. Moving up if it is less denser than air, and this process is known as upward delivery. Upward delivery. If this one is the upward delivery. This one, because the gas is more denser than air, and this one is counted as downward delivery. If it is one upward delivery, and this one is downward delivery. And both of them counted as air displacement. This one is counted as a water displacement. Water displacement sometimes preferable than the air displacement because the water is used to wash the gas produced. Sometimes like this. This one, if you would like to collect the gas only, how about if you would like to collect the gas and measuring its volume? What will you do? In a case like this, you have to ask yourself a question. Open the area experiment to close the area experiment. I didn't get it. Method for collecting the gas and measuring its volume. And you have a closed area experiment. Closed area experiment, yani the gas which is collected can be collected through delivery tube. So in a case like this, I'm going to use just gas syringe. And in this case, syringe will be, the gas will be collected and its volume also will be measured. This one, we are going to use it several times in something we call kinetic chemistry and rate of chemical reaction. How about if the experiment taking place in open area experiment? Yani I have more than one gas are produced from the same experiment, one producing from here and one producing from here. What will you do now? Just separate the two gases. Or use inverting or inverted measuring cylinder. The gas will be collected in this measuring cylinder, and from the graduated values here, you can predict the volume of this gas. Give this for measuring the volume of the gas, collecting it and measuring its volume. This one for collecting the gases and measuring the volume, or the physical quantities which require to be measured at the science lab. Then what? Now you can collect the gas, you can measure the physical quantities. Don't forget, we're talking about something called the purity. If the substance which we have is already impure, you're going to use the science lab to separate the component of this mixture. How can you separate the component of the mixture? You have to decide the type of mixture first. Type of mixtures will be decided according to the component of this mixture. It may be solid mixture. The two components are solid. Iron and sand, sand and salt, salt and sugar. Or it may be solid, liquid, salt and water, sand and water. Or it may be liquid, water and oil, water and alcohol, petroleum components. The component of the mixture giving us information about the method which will be required to separate those components. We have a definite rules in case of solid liquid or liquid liquid. We don't have any rules in case of solid solid. I don't understand. What's rules? What's definite rules? What is that thing? I mean, the component of solid mixture or the method required to separate them cannot be predicted or detected till you know what is the components which we have here. Like in case of solid liquid, you have a definite steps you're going to follow it to separate the components. If you know them or even you don't know them. Till now, I don't understand. Let's start. To separate the solid mixture, we try to make it simple for you, to simplify it for you. That's why we put for you 3 actions. One of them is action of magnet. When exactly you can use a magnet? If one of them is magnetic and the other one is non-magnetic. Yani you have iron and sand, just use magnet, iron will attract to the magnet. How about if I have iron and nickel or cobalt, magnet is useless for us. How about if I have a sand or salt or plus salt, magnet is useless here. So you can use magnet if you have magnetic and non-magnetic. But this one is the first action, can be used if you have a magnetic and non-magnetic substance. How about the second action? Action of solvent. You have one soluble and the other one is insoluble. I have sand and salt. What will you do? I'm going to add a water. The salt will dissolve, the sand will not. Simple filtration can separate them after that. But this one, the action of solvent. This insists us to know which one is soluble, which one is insoluble. And this one we're going to give it in a brief detail. So, okay, this one, the action of solvent. Sorry. The third action, which we have, the action of heat. Action of heat. Heat for the solid substance, yes. Maybe, man, you have iodine and salt. Once you have iodine and salt, by heating them, what will happen? Iodine convert direct from solid to gas in the process. We call it sublimation. So it can be separated. There are three actions we have already for the solid-solid mixture. Action of magnet, if you have magnetic and non-magnetic. Action of solvent, if you have soluble and insoluble. Action of heat, if one of the components can convert direct into gas, like iodine. This one for the solid mixture. How about if you have a solid liquid mixture? Follow me if you don't mind. Is the solid soluble or insoluble? And this solid is soluble or it is insoluble? Maybe it's insoluble. Now, move with me, please. The size of the particle of the solid, small size particle or larger size particle? What's the difference? That makes a difference. If it is small size particle, you're going to use filtration process. Filtration. Filter funnel with a filter paper. You are going to use filtration here. I said filter funnel with a filter paper. The residue remains here, the filtrate getting down here. The insoluble one stays here. How about if it's larger size particle, what will you do? Decanting. If you have a beaker somewhere like a gravel inside it, what will you do? Just pour in the liquid. If this one is just decanting process. We call it decantation. Decanting boron liquid from the large insoluble material which we have here. How about if I have a soluble one? What will you do? Soluble one? Yes. Like what? Salt in water, sugar in water. Now you need to ask yourself a simple question. Is this solid thermally stable? Or thermal unstable? What's the meaning of thermal stable or the meaning of thermal unstable? Thermal stable does not affect by the action of heat. Just heating it, nothing will happen. It will convert from solid to liquid to gas. That's the only thing. Physical change takes place, not chemical change. Will not convert to another substance. Will not decompose by the action of heat. This one known as thermally stable. Thermally unstable, it will decompose by the action of heat, converting into another substance. Example if you mind, for sure. If you heat the table salt, what will happen? Nothing. It will melt and evaporate. If you heat hydrated copper sulfate, it will decompose. If you heat sugar even, it will decompose, burn out. If the substance which we have is thermally stable, you're going to use simple distillation. Simple distillation. If it is one, the simple distillation will be used here. If it is thermally stable. How about if it's thermally unstable? The salt or the solid substance decomposes by the action of heat. You're going to make something, we call it crystallization. Let's see the difference between them in a brief, quickly, please. I have the solid substance with water here. And I would like to separate them by something we call it distillation. What's distillation? Distillation is evaporation and condensation. Distillation is the word distillation, evaporation plus condensation. Both of them giving you distillation. Distillation equal evaporation plus condensation. Evaporation takes place by heating. Condensation takes place by condenser. Small equipment to convert gas into liquid. Moving inside here an internal tube. And I'm cooling down by water in from here and water out from here. And the gas will convert into liquid here. What will you do? I'm going to evaporate all of the liquid. So the liquid will be collected here and the solid remains here. This one is what? Simple distillation. Simple distillation. How about crystallization? You cannot evaporate all of this water. Why? Because once all of the water is moved away, the solid will expose to high temperature and decompose. So you are going to convert your solution from diluted solution to concentrated, from unsaturated into saturated by high temperature. You're going to decrease the solvent, increasing the concentration of the solute which we have. Till the crystals appears here, you're going to stop heating, cooling down. The crystals will increase and can be separated by filtration. This one is known as crystallization. The point of crystallization can be detected by the appearance of crystals, even at the container wall or even at a glass rod inside this container. But this one for the crystallization. Again, I'm going to move to the type of the mixture. There was a remaining one, which is liquid mixture. How can you separate the liquid mixture? Again, just follow me. They are forming one layer. I mean, they are miscible, or they are forming more than one layer immiscible. If they are miscible, like alcohol and water, or they are immiscible, like oil and water. If they are immiscible, it's easy. I have oil and water, and they are immiscible, forming more than one layer. So this one will be the water, and this one will be the oil. Easy, you get separating funnel. Open this tab, the water will getting out first, and then the oil there. How about if they are miscible? So you have more than one component, and they have different boiling points. So I'm going to use distillation. Which kind of distillation? Because I have more than one solvent here in this case, I'm going to use fractional distillation. So distillation, two classes, yes. One of them is the simple distillation. The other one is fractional. Simple distillation, if you have only one solvent, will be formed. Fractional, if you have more than one solvent, or more than one liquid, will be produced. If you don't mind. As we say, if we have here liquid A and B and C, we have fractional column, this one, to control the fractions produced. We have the condenser here to condense the liquid formed. We have a thermometer here to predict the temperature of the process. And the bulb of the thermometer in front of the condenser, which we have. This one boils at 70, this one at 80, this one at 100. What will happen? By heating temperature at 70, the A will start boiling and evaporating. And during boiling and evaporating, the temperature will be constant. Yani it's not needed for you to increase or decrease the heat. Keep it as it is. Just observe the thermometer. Once temperature is constant, one of the components now is removed. Sudden change takes place in temperature, and temperature starts increasing to be 80. In this case, B. After that, at 100, A or the C will be reduced. But those are the methods which are needed to separate the component of the mixture if it is liquid-liquid mixture, miscible or immiscible. Quickly, if you don't mind, please. Remind me with the kind of mixture which we have. You told me solid mixture, solid liquid mixture, liquid mixture. In the solid mixture, 3 actions. Action of magnet, magnetic and non-magnetic substance are present. Action of solvent, soluble and insoluble substance are present. Action of heat, substance converted into gas in a sublimation process. For the solid liquid mixture, remind me, soluble, either simple distillation or a crystallization. Insoluble, either filtration or decantation or decanting process. Liquid, miscible, fractional distillation because they have different boiling points. Immiscible, separating funnel because they are forming more than one layer, can be easily separated. This, how to separate the component of the mixture as we did say before. We have another class of mixtures, gas, we did separate before. They can be separated by diffusion as we just said because they have different rate of diffusion as they have different molecular masses. If it is difficult, convert them into liquid and separate them by fractional distillation. But for the gas and the gas mixture, you can separate them by either diffusion, because they have different molecular mass and different rate of diffusion, or fractional distillation after converting them into liquids. We have another method of separation, this one known as a chromatography. For the chromatography, this one depending on the solubility of the component, which one of them is more soluble. You're going to use something we call it chromatography paper, filter paper, normal one. Starting line with the pencil, because pencil is made of graphite, insoluble in all solvents. And we have the components here. Those are the components, yes. And this one is the solvent. And then what? Because this one is filter paper, will absorb the substance of the solvent. The solvent will start moving like this. And what do we have here? We have the mixture. The mixture components are soluble in this solvent. But this one is the solvent which we have. This one, gated line, or we call it starting line, doesn't make a difference with me. This one is the mixture. And the main condition is the mixture component need to be soluble in this solvent. According to their solubility, they will be separated. The one which is more soluble will be at the top here. The one which is less soluble will be at the bottom here. The one which is insoluble will remain here. If this one is more soluble, this one is less soluble. The remaining one, this one is insoluble. According to their location, you can decide which one is more soluble, which more is less soluble. I'm supposed to know them now. It's easy. If you have a mixture and you have pure substance, how do you know this one is mixture and this one is pure substance? We said before, we can use chromatography to test the purity. If you get only one spot, that means this one is a pure substance. If you get more than one spot, 2 or 3 or 4, This one is mixture. Till this moment, I don't know. I'm supposed to know the component which I have. I just, man, wait. Now I have a mixture here consists of 3 substances. And I have 3 pure substances, this one and that one and that one. This one is A and this one is B and this one is C. And the mixture which we have is consists of 3 components. Component 1, component 2, and a component 3. The rule said 2 components at the same level are identical. Yani if A reaches this point, يبقى 2 and A at the same level, this one is A. In this case, 2 is A. If B reaches this point, يبقى 1 and B at the same level. In this case, 1 is B. If C reaches this level, so they are in the same level. You can observe it here. Yibqa 3 is C. So from the rule, 2 components at the same level are identical. 2 components at the same level are identical. Man, if you don't mind, sometime we're making chromatography because the process depends on the different solubility. Yes. So we can use it to separate amino acid or carbohydrates. Yes, you can. But amino acid and carbohydrates are colorless, so they will not appear here in this paper. Being colorless, this one is not the problem. Yes, this one is not the problem. So why this one is not a problem? Because we're going to add a locating agent, a chemical substance added here to predict the location of colorless compounds. Even this one for the chromatography as a method of separation. And this one about the first topic. Actually, this topic is common between the 3 boards, CIE, AQA, and Edexcel. This topic is a complete topic in CIE. Separated part, state of matter is a part, and a mixture is another part in both AQA and Edexcel. Like it's already present there. For CIE, as we would say, this one is counted as one topic. AQA, the first part in paper 1, the second part, the mixture is present in paper 2, both Edexcel and AQA. Anyhow, as we would say, it's counted as a complete topic, and we finished it now. And as we would say, after finishing any one of the topic, we're going to provide the student with a complete note. For example, this one is the note for the CIE, Cambridge student. You're going to find a classification, the notes, you're going to read it for studying this topic. All of the information we just said, giving by one or more than one way, and complete tabling for the information. Complete tabling for the information which we have. And information giving as simple table by the end of this topic. Okay? And by the end of this topic, you're going to find classified question. Which process causes the greatest increased distance between the particles? This one is sublimation, changing from solid to gas, increasing distance. A stearin put 25.0 dilute hydrochloric acid in the conical flask and 2 grams. So which equipment required to measure 25? Which equipment required to measure 2.5? You get it? It's okay. Those are the kind of the question which we have already by CIE. Sorry, there is a small party here we're supposed to know. Sorry, for a moment, quickly. Here it is. For the chromatography, If you would like to know the components which we have here, what it say, we can compare it with standard pure material. However, if I don't have a standard pure material, we're going to use a value known as RF value. Distance covered by the component over the distance covered by the solvent. This one is RF. Yani I'm going to make chromatography this one because I forget it now. Now we're going to complete that. This one is a component and this one is a solvent front. Distance, this one is X. Distance, this one is Y. X over Y gives you the RF value. Rate of relation factor is what it say, rate of flow. This one gives you RF value for each substance we have, specific RF value, but this one is identical for each substance. Again here, but those are the class of the question which we have already. You can observe the question and you can find the answer for this question already at this area here. This one solid liquid gas, and you can observe those are the kind of question which we have in paper 2. In CIE you have paper 2 and paper 4. Paper 2 questions, you can find it like this. Paper 4 question you will find after paper 2. This one. Simple questions like this can be solved. This one's related to the topic which we have, as we say, this one's classified questions. We're going to make a complete class for solving those questions here. Every time we're going to take the class and give you some time for reading this class. And then next time we're going to talk about the question or solving the question. For the AQA, this one is the notes. For sure, the notes which we have for the AQA provided already last year and this year from Oxford. And we are not putting it ourselves, but this one is the new edition. That's why we took it from Oxford already. And by the way, you can use any one of the books other than the notes. You can use the notes if you want. You can use the book. This one from the Oxford one. It's okay. And even the classified questions after this topic, you're going to find it at Oxford website. You're giving it to us. Here it is. Give this one to the student. They said so. Practice for the students from these questions. And we did add already some question from AQA, as we did say, from the past papers. And there is a very nice website. Everybody knew it. This one is the Save My Exam website. This one, a question in Save My Exam, multiple choice question, CIE, can be solved here. This one is ammonia. You can solve a question like this. What do we have here? Ammonia, the molecular mass 17. This one, hydrogen chloride, HCl, the molecular mass 37.5. Heavier than that one. So the meeting will be around at, that's right, at D. Because ammonia diffuses faster than hydrogen chloride. And then complete your experiment, which we have here. This process is, you know, changing from solid to gas, process known as sublimation. All of the questions are going to find it by this way. Propanone C3H6O is a liquid at room temperature. What is the boiling point for pure? Number one, if it's pure, it will be fixed temperature. So don't take variable. If it is liquid, So its boiling point will be higher than the room temperature. So don't take this, take this. Is it clear for us how to solve the question? Yeah, this one is a multiple choice question. You can find, say, my exam also. I see it's there. Yeah, anyhow, you're going to find it when you work with this issue. Like AQ questions, this one is Cambridge 1. Paper 4 questions. The motion of particles in case of solid nitrogen and this nitrogen gas. Solid and gas. Vibrational motion, random motion. All of this question will be simple by this way, as you can observe. For the AQA and Edexcel almost will be similar in the questions. You can observe this one is a kind of question also in those platforms. Some multiple choice questions, some essay questions at the same time. Because in Edexcel and AQA, I mean Oxford 1, you didn't have multiple choice paper, multiple choice part of the paper itself. And in Oxford or AQA, you have only 2 papers. In CIE, you have 3 papers. In Oxford and Edexcel, you have a separate topics. Paper 1 has definite topic, paper 2 has another definite topic. Like in CIE, you have the whole syllabus, all papers, except paper 3, which relate to the practical part only. As we did say, we are explaining the topic in one of the classes and making practice question a complete class. I did make this one recorded class because, you know, this information you take in grade 7 and 8 and 9. So no need to waste your time. And this information, again, we just refreshing your brain by this topics information. Next class, inshallah, will be given as online classes. Saturday, we have a free online class for also one of the common classes, atomic structure and chemical formula. This one for the 3 boards. And you can attend the class if you want. As we would say, this one will be free online class. Anybody can attend this class and you can join it. You can join my classes, like you can send me WhatsApp if you would like to join the classes. This one is my view, my information, all of it present in the first page in this notes. I'm going to send you the notes anyhow, whether you're going to continue with us or not. But the arrangement of topics differ from Cambridge to the CIE and all of this from Cambridge to Edexcel and Oxford, just the arrangement. Like in the topics, all of it are there and here. All of this information, this one my contact number if you want it at any time, and this one is my email, the WhatsApp, and this contact number. I'm going to put this recorded video all of the groups for anybody can use it. If you would like to join the class at any time, you can join it. And actually, like some people care about the money, and I think here, don't care about this point. This one is the last thing, talk about it. If you can pay, I'm going to take money. If you cannot pay, I'm going to take more than money. Thanks so much. See you next class.